actually record it this time. Okay, superb. All right, guys, so as I said, for whatever reason, I don't know, I think I just didn't click the button the other night, didn't record depreciation. Okay, so just a wee recap, so we've got it recorded and we can have a wee check at it. Okay, so depreciation, opposite of appreciation. Okay, so depreciation, okay, when the value drops. Okay, so we've got a starting value, okay, and we get given a question along the lines of the value will drop 3% per given period. Okay, and we need to calculate how many periods that it's asking us to calculate. Okay, so we're following that same method where we're creating a multiplier. Okay, something called a multiplier. Okay, so we're multiplying the original value for depreciation by a number less than 1. Okay, so we spoke about something called equivalence. Okay, you don't need to copy this down if you've got it. Okay, if we've got equivalence, so 100%, it's the same as writing in fraction form, 100 out of 100. Okay, which also gives you the number 1. Okay, so that original value is 100%. Okay, so if we're depreciating, we're reducing by a number less than 1. Okay, so it's going to take that original value and it's going to drop down. Okay, so if we do an example, okay, 30,000 COVID cases were reported on 30th of January. They expected it to drop by 3.5% per day. Over the coming week. Okay, so pretty normal thing to see in the media. Okay, so over the coming week, we're expected to see it drop by 3.5%. Oh, up overall week. Okay, how many cases? Do we expect on the 6th of Feb? Okay, so after 1 week, okay, or 7 days. Okay, so percentage special depreciation, converting back from or reversing a change in percentage as well. They like to give you a story, full story. Okay, you just need to extract that data. So we've got an original value, 30,000. Original value. It's excitement. Okay. And we've got a depreciation percentage of 3.5%. Okay, so we want to find out a multiplier. Okay, so to find a multiplier, we're taking that 3.5% away from 100. Okay, so we could do 100 minus 3.5, okay, which would give us 96.5. And then take that figure, divide that by 100, okay, to give us our multiplier. Okay, or conversely, take this figure here, the 3.5, okay, divide that by 100, get 0.035. Okay, and then our multiplier would be 1 minus 0.035. Should give us 0.965. Okay, so essentially after every day, we've got 96.5% of that original value. Okay, or 0.965 times that original value. Okay, so that's our multiplier. Depreciation, that number needs to be below 1. Okay, if we're timesing something by it, it needs to drop that amount. So our new value equals original multiplied by our multiplier. Okay, remember that is to the power of the number of years. Number of years. The number of periods. Okay, in this case, number of days. Okay. Putting that in our calculators, we'd have 30,000 multiplied by 0.965 to the power of 7. Okay. Remember, different calculators have different buttons, so if you're unsure about this stage, give me a wee shout. If we're together on Thursday, perfect time. Okay, and we'll have a wee look at it. 30,000 multiplied by 0.965. That's to the power of button, and it's to the power of 7. Okay, so we're getting a value 0.3378. Okay, remember to put whatever they've put. Okay, cases expected. So always give those units at the end, whatever those units may be. It could be something completely obscure. Okay, it might be pounds. So dog barking. Okay, it could be pounds, usually pounds. Okay, it might be a monetary value. It could be a number of days. It could be a number of cases. It really could be anything. But remember, try and put those units. Okay, you usually get a mark for those units. Okay, so that's sort of depreciation. Okay, so nothing too bad. Very similar to appreciation. Okay, but it's a number below 1 that we're taking away. Oh, sorry, number below 1 that we're multiplying it by becomes a multiplier. Okay. The other thing that we did on Thursday that wasn't recorded was calculating original value also known as reversing the change. Okay, so let's see it written as both ways. Okay, so we're given a value, it's showing a percentage change. So you often see this if something's been on sale. Okay, you'll see it at 75% of the original cost or whatever it is. Okay, or 25% off. Okay, so an example. Okay, pair of trainers, £60, 30% off sale. What was the original? Okay, so if it's £60, okay, £60 and it's 30% off. Okay, means it was 100 minus 30, so it's now 70% of the original value. Okay. We want to find 1%. Okay, so we've got 70%. Impossible to go the other way, okay, so it's impossible to go straight from 70 to 100, okay. The easiest way to do it is find out 1% and then multiply that whole answer by 100. Okay, so if we want to find 1%, we divide £60 by 70, okay. So 60 divided by 70 equals 60 divided by 70 equals 0.8, and I'm going to round it up. Okay, so 1%. Okay, the total value is 86 pence. Okay, to find 100%, okay, our full value, take our 1%, okay, get our 100%. Okay, so £86 was the original cost. Quick and easy way to check that, just multiply that by 0.7, okay, just to go back to your answer, take you back to your answer. Okay, but that's reversing the percentage change. Okay, so I just needed to cover that, just so we were happy, so it's recorded. Okay guys, any questions before we move on? Okay, so going to move on to statistics. Can't spell. Statistics. Okay. You'll find this or questions with it in the Unit 3 apps handout. Okay, so I'll refer to the Unit 3 applications handout. Okay, terrible lighting off that iPad. So that's not that. That's BBC Bytes, right? This one. Okay, so in your middle, remember, just this app pack here. Okay, so statistics, it's in pack 3, okay, in the applications unit. Okay, and you'll find it towards the end, bunch of questions. So I will use this tonight, so we will be working from page 60. Okay, so page 60 in handout 3 and booklet 3. Okay. Another good thing to read or good thing to refer to is the dynamics notes, again in Moodle. Okay. Dynamics notes breaks it down pretty well for everything we're going to cover. Okay, so if you ever want something else just to look at, a wee reminder, okay, dynamics notes, and it's page 92. Okay, so we're quite far on now, page 92. Okay. Right, let's have a wee look at it. So if you have both of those open, okay, and I'll refer to them at some point. Okay, so 2 types of questions for statistics. Okay, for the real part of statistics. There's also a straight line part that we sort of covered, okay, which I won't look at tonight. But for statistics, for standard deviation, and for things like median and mean, okay, there's two types of questions. Okay, type 1. Looks at something called the median, and we'll ask about something called the interquartile range, or the semi-interquartile range. Okay. Type 2 question that could come up, asks about something called the mean. Okay, and we'll ask you to work out the standard deviation. Okay, so these are the two types of questions that might pop up. Okay. This standard deviation uses what looks like quite a technical formula, but we'll break it down. Okay, not a lot of people like it, okay, for that simple reason. But you're given it in the exam paper, okay, the formula, and it's just a case of putting in or substituting in the right numbers. Okay, these two terms mean the same thing, really. Well, they don't mean the same thing, but they talk about the average. Okay, so for a group of numbers, for a collection of data, the median and the mean look for an average. Okay, these interquartile ranges, semi-interquartile ranges, and standard deviation. Okay, they look at how widely spread the data is. Okay, now that will make sense once we come and we look at what comes up. Okay, you get given a bunch of data and you just need to work out, you need to work out what the average is by either finding the median or the mean, okay, and then find the interquartile, semi-interquartile, or standard deviation. Okay, what these questions ask you to do is interpret that data. Okay, so it's often a wee bit extra you need to do. So you need to take in that data, you need to work it out, and then you need to refer back to it. So being able to explain what's happening in a question. Okay, so again, it's one of these questions that will give you a wee story. Okay, it'll talk about the temperature of the weather. Okay, or it'll talk about the amount of, well, we'll do an example later on, which is matches in a matchbox, or daft wee things like that. But what it's asking you to do is refer back to that. And there's a few things that people miss out, and they miss really easy marks. Okay, so we'll make sure we're comfortable with that and we cover it. Okay, it's really just about describing what your answers are and comparing two sets of data. Okay, so type 1. Okay, that's the median questions. Okay, the median questions that looks for a median and then asks you something about the semi or the interquartile ranges or semi-interquartile ranges. Okay, so let's go through what each of those terms means. Median. Okay, it's the middle number in a list of data so a middle number in a list of data that has been organized okay, typically smallest to largest. Okay, now in the question you might be asked to organize that. Okay, so it's not always given to you in an organized fashion. Okay, so to find the median, putting it to smallest to largest, okay, it will then be the middle number in that. Okay, now that's not always an exact number, but again, we'll look at that in the example. Now the median is the second quartile. Okay, so it's known as the second quartile or quartile 2. Okay, Q2, okay, Q level 2, whatever you want to call it. Okay, so it's the middle. Okay, and what the quartiles are is you splitting up the data, the numbers, okay, into 4 equal parts. Okay, and that goes by the number of numbers. Okay, so 4 equal parts, and that's split by the number of them. Okay, so quartile, pardon me, is splitting the list of numbers into 4 equal parts. Okay, so quartile 1, also known as the lower quartile, okay, it could be referred to as a couple of things, okay, Q1 lower quartile, okay, Q2 is the median we just covered, and Q3 is the upper quartile. Okay, so if we split that into 4 equal parts, okay, we've got first section, then we've got Q1, second section, Q2, third section, Q3, and then the last section. Okay, so those numbers in between, this will make more sense when we put some numbers to it. Okay, is the lower quartile and upper quartile. Okay, so we've split it up into 4 equal parts. Okay. The interquartile range is Q3 minus Q1. Okay. Interquartile range. Okay, sometimes referred to as the short interquartile range. Okay. So what the quartiles are looking at is looking at the spread of data. Okay, so if you think about the spread of data, how far apart Q3 and Q1 are, is telling you, something to do with that. Okay, it can give you some sort of analysis of how spread out the data is. Again, that's important. We'll look at why. The semi-interquartile range does something similar, but for reasons known only to statisticians, divides that by 2. Okay, so again, it's Q3 minus Q1. We're dividing that whole thing by 2. Again, the way we use it is just to look at distribution, how far the numbers are spread. Okay, so when we do the analysis and when we're asked to make a comparison, we use both of these in the same way. Okay, but it's important that we just pick the right one. These you do not get in the exam paper. Okay, so you're expected to know that. So Q3 minus Q1 is the interquartile range. Semi-interquartile range is Q3 minus Q1 over 2. Okay, so you're expected to know that. Hopefully, by the time we're hitting prelim or hitting the exam, we've done enough examples that it sort of just rolls off the tongue. Okay. The data, okay, the information is sometimes given to you in something called a box plot. Okay, now importantly, you'll never get asked to draw a box plot. Okay, but you may have to read information from it. Okay, and all a box plot is it plots in a number line. Okay, the lowest number, Q1, Q2, Q3, and the highest number. So it will look something along the lines of line at the start, straight line to box. Okay, so that first line will just be the lowest number. That will be Q1. That line's Q2. That line's Q3. My God. Okay, and then that last line is the highest number. Okay, so your data might be presented to you with a box plot. Obviously, it won't say Q1, Q2, Q3, but that's what it's telling you. Okay, so those boxes, those separators, okay, are telling you where those figures are. Okay, so that Q2 in the middle is going to be the median. Interquartile range, Q3 minus Q1. Semi interquartile range would be that divided by 2. All right, so again, you won't be able to, you won't be asked to draw a box plot, but you might be able to, you might be asked to read information from it, extract data from it. Right, let's put this into a question and actually do one of them. Okay, just writing out letters probably won't be telling you much. Okay. They like to put it in a nice wee story. So example, the midday temperature in something called Brantford. Okay, was recorded over 9-day period. Okay, so we're going to get 9 bits of data. Okay, temps. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the temps at midday in some place called Grantford, recorded over a 9-day period. Okay, and those temperatures were 4 degrees, 7 degrees, 4 degrees, 3 degrees, blah, 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 blah. Okay. The question, calculate the median, find the median, and semi interquartile range. Okay. Now, you think back to what the median is, okay, and the semi or interquartile range is. First thing I said to do was we need to list them from lowest to highest. Okay, so step 1 for us, okay, would be list them small to high. This is a case of just going through those numbers and ticking them off as you go along. Okay, so your smallest number is 3. Okay, it was 3, 3, 4, 4. Okay, as you go along, just tick them off. 3, 3, 4, 4. Make sure you've not missed anything. There's a 5 there. 5, 6, 7. Okay, 5, 6, 7. There's no doublers there, and then it goes 9, 10. Okay. So the median is the number in the middle. Now there's 9 numbers. Okay. So if we want to find the middle of that, it's that number there, number 5. Okay. From that point, you can use brackets if you want. From that point, we've got 4 numbers to the left. We've got 4 numbers to the right. Okay, so the median Q2, median is 5. Okay, simple as that. Okay. Q1 is the midpoint, okay, on the left hand side. Okay, so remember we're splitting it up into 4 equally spaced packs of data. Okay, so the midpoint between 4 numbers is in between number 2 and 3. Okay, so it's in there. That'll be Q1. Because it's in between 2 numbers, we're going to have to do 3 plus 4 divided by 2 to get that number in between. Okay, and it's 3.5. Okay, so to get the exact middle of those two. Okay, so Q1 is 3.5. Q2, on the other hand, is that number in there. Okay, so it's in between that 7 and 9, not Q3. Okay, so again, we can just do 7 plus 9 over 2 to give us that answer. It's 8, obviously. Okay, so 16 over 2 is 8. So Q3 is 8. Okay, so that's us got our data to allow us to work out or to answer that question. Okay, so it's asking the median. That's just 5. Remember to put the units. The semi-interquartile range is Q3 minus Q1 over 2. So that's 8 minus Q1, which is 3.5 over 2. 5, so that's 4.5 over 2, which is 2.25. Now it's on its own, 2.25 doesn't mean anything to you, okay? But we use that to compare against other data ranges, okay? So this is a measure spread of data. Okay, now sometimes that's quite important how far out these numbers are spread. Okay. Second part of the question will give you something to then compare those figures to. Okay, that median and that semi-interquartile range. Okay, so B, say over the same 9 days. Okay. Midday temp and Endoch was recorded. Okay. The median temp was 8 degrees. And the semi-interquartile range was 1.5. Okay, that will give you a question like make 2 valid comments comparing the temps Grantford and Endok. Okay, so second part of the question always asks you, okay, well, here's another set of data, okay, with the median and either the interquartile range or semi-interquartile range. Give us a comparison. Okay, give us a comparison. Now this is where a lot of people always miss important parts of information. Okay, what it doesn't want you to do is state the obvious. It wants you to give a wee bit more depth of thought to it. Okay, so if we look at the median for Grantock, okay, that was, what did we work out? 5 degrees. Okay, median Endok we've worked out at, or we've been told, is 8 degrees. Okay, so the middle number in both the data ranges over those 9 days shows Endok as being higher. Okay, so we need to put that in words. Okay, now a very important word that we need to use here is average. Okay, so we need to put in this sentence something about the average, and that shows us, or shows the examiner, that you know what the median is. Okay, so the median is a type of average. Okay, so something along the lines of the median temperature is higher in Endok, therefore on average it is colder in Grantham. Okay, now that word is key. Okay, so don't just say the median is higher in Endok. Okay, you need to state the median and the median what, so the median temperature is higher in Endok, therefore on average. Okay, so you need to refer to the question and refer to you knowing that the median is an average. Okay, so really important bits here. So refer to question and show examiner you know median is an average. Okay, wee bit of a pain in the arse, but easy marks. Okay, easy to miss, easy marks to miss, but if you remember to do it, easy marks to get. Same again, so that's your first statement. I asked for 2 statements. Second statement be about your semi-interquartile range. So your you don't need to write this out again, okay. Your semi-interquartile range for Granton was 2.25. Is that working? Okay, semi-interquartile range for Granton was 2.25. Semi-interquartile range for Endok was 1.5. Okay, now what does that mean? That means the spread of temperatures in Endach wasn't as wide as the spread of temperatures in Granton. Okay, that shows that it's more consistent. Okay, not being spread out as far means it's more consistent. So the temperature in Endach is more consistent. Okay, it doesn't vary as much. Okay, so lots of things like this. So the SIQR is higher in Granton. This means, okay, that's the important bit, this means the temperatures refer to the question, okay, the temperatures are more spread out than in Endach. Or you could say more spread out or less consistent. Okay, so you can use either one of those lines, okay? More spread out than Endach. Important that you show you understand SIQR means spread. And it's important, refer to the question. Okay. That bit isn't hard. It's an easy 2 marks, but you need to do those things. Refer to the question and give a wee bit of understanding about what those numbers are. Okay. What is good is the dynamic notes. So in middle, okay, so in middle, these notes here, these dynamic notes, lost. These dynamic notes give you this, okay? So, comparing statistics, okay, gives you a wee note about comparing statistics and what they're looking for. You would get no marks for these following, okay? No marks for these, no marks for this. You would get marks for these sentences. So it goes through in a bit more depth, maybe, than I have, okay? Gives a wee bit more reasoning, okay? Talks about, no mention of what it is, okay? So refer to that question, okay? What else does it say? Don't just state the obvious. So something's got a lower or higher, median or mean, okay? So I like that wee bit. So have a wee read at that. So after tonight, when you're doing some of your own questions, when you're practicing your own questions, have a wee read at that and just make sure you're sort of comfortable and understanding what it's looking for, okay? So it's talking about temperatures again in this. On average, the temperature in Aberdeen is lower than London, and the temperature is less consistent, okay? Temperature in London is higher and more consistent than Aberdeen. Referring to the question, putting a bit of understanding in there, okay, things like that. So have a wee read of that. That's page 95 of dynamic notes. Okay, so I quite like that. Okay, it doesn't go into too much depth. Shows you what we just spoke about there. Okay. Okay. So have a wee look at that in your own time. Let's do a couple more examples. There's a lot of examples. My God. Okay, what's the time? 7 o'clock. let's have a wee look at a past paper question on this. Okay, so we don't let the night go. So wee past paper question, we'll go through this, have a wee break. Okay, have a wee break and then we'll do the other type of question. Okay, so past paper. Manufacturer, if you can read my writing by now, okay, of matches, which is random, but we'll go with it, claims that, whatever I pressed there, turn that off, claims that on average, okay, what am I doing? Sorry guys. Okay, manufacturer of matches claims that on average there are 60 matches per box. Okay. A sample of 11 boxes was taken and they contained, what a job doing that sample, 58, 62, 60, 65, 59, 60, 59, 62, 61.
Can I just ask what past paper this was?
You can ask. I don't know. I'll need to check. I
That's
didn't.
right.
I don't know. I'll need to find. Okay, so total 6 marks went through. Okay, so question A. Okay, from the data, find the median, the lower quartile, which is Q1, and the upper quartile. B would be comment on the claims from the company. Okay, so we'll refer back to the claims. C. C, find the semi on interquartile range. Okay, then there's part D, which we'll cover in 2 minutes. Okay, so let's look at A, B, and C first, and then we'll cover part D in a second. Okay, part A, frustratingly, it's just going through those numbers, just ticking them off. Okay, save you the pain. Done it. 58, 59, 59, 60, 60, 61, 61, okay, so you can go through and tick them off, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so median Q2 okay, is the middle number. So bang in the middle. So bang in the middle, 11. Okay, would be the 6. Now 1, 2, 3, 4, 5. Be this number here. Okay, that gives me 5 numbers to the left, 5 numbers to the right. Okay, Q1 in that case. Okay, that would be the low, or the lower interquartile. Oh, sorry, lower quartile. And then Q3 would be that number there. Okay, so we'll split it equally into 4. Okay. So from the data, find the median, the lower quartile, and the upper quartile. Okay, so your lower, median, upper. Comment on the claims from the company. Okay, the company claimed that on average there were 60 matches per box. Okay, the average we've found, okay, the median is actually 61. Okay.
Sorry to interrupt you. Can I just ask a question?
Yep.
So do you know how in the last question we did step 1 it was 3, 3, 4, 4, but we had to find the middle number because there was only 4, and we had to do 3 plus 4 then divided by 2.
Yeah.
Obviously this one there's 5 numbers and it gives a clear middle. So
Yep.
do we just leave it at that, or do we need to divide that by 2?
Great question. Yes, no, we leave it at that.
Just leave it. Okay.
Yeah, so I did that because we were in the middle of 2 numbers.
Yeah.
Okay,
Yeah.
so I saw it, should have made that
Cool.
clear. Yeah.
No, you're fine. Thank you.
So yeah, being in the middle of 2 numbers, okay, we add those 2 numbers together, then divide it by 2, and that gives us that sort of result in the middle of that. Okay, having a Q1 and Q3 with an exact number, okay, makes life a lot easier. Okay, so good question. Okay, to comment on the claims. So the median, so that was A. B. Okay, the median is a type of average. Okay, now it might not be the average you're used to. Okay, and we'll cover that later on. Okay, but it is a type of average. Okay, so the average that we found, the median. Okay, the median is 61 matches from the sample. This is higher than the figure of 60 claimed. Company, okay. Therefore, on average, there is one more match per box. Now that comment might be a bit overkill, okay, but it certainly refers to the question, and it gives us, or it gives the examiner, an understanding that you know that the median is an average. Okay, so the question asks about an average, you've stated matches, you've stated everything you need to. Okay, a lot of writing there, but it gives the examiner everything that they want. Okay. C, it's a semi-interquartile range. Okay, semi-interquartile range. That's Q3 minus Q1 over 2. Q3 was 62. Q1 is 59. Okay, so 62 minus 59 is 3. 3 over 2 is 1.5. Okay. On its own, that doesn't tell us much. Okay, semi-interquartile and interquartile only tell us something if it's used for some sort of comparison. Okay, so semi-interquartile range is 1.5. Okay, so the last part of this question is part D. Okay, part D asks a different sample. All boxes was taken. Okay, and they gave this in a box plot. Okay, they put the numbers 54. Okay, so a different sample of boxes was taken. Okay, and it gave the results in a box plot like that. Okay, that should be 58. My pen's not too accurate tonight. Okay. So what are we looking at with that box plot? Okay, well we said that n number is going to be the lowest number. Okay, so that's the lowest number out of the sample. Okay, and that high, the opposite end is going to be your highest number. Okay, that sort of takes them out of our sort of analysis. Okay, so we don't really need those two numbers. It just sets those sort of limits. Okay. First thing we're interested in is that Q2, that median. Okay, that median we can use as the average, or we are using as average. Okay. That's Q1. Okay, the end of that box. Okay, that line there. It's giving you 56. And that one is Q3. So it's just a different way of presenting it. Okay, don't think it gives a number of samples, but it's just a different way of presenting the numbers. So it only states 5 numbers on that box plot. It's the 5 most important numbers, the 5 numbers that you need for that comparison or analysis. Okay. Does this support the manufacturer's claim? Okay. What it's looking for is essentially the same as we said in B. Okay. So in this case, the median is actually lower than what the manufacturers claim. Okay. So on average, it's two matches per box lower. Okay, so it doesn't support. Okay. The manufacturer's claim because the average is lower. Okay, and that's all it's looking for there. That whole thing is worth 6 marks. Okay, it doesn't ask you to compare the interquartile range, the semi-interquartile range. If there was anything about the semi-interquartile ranges, okay, you just work out the semi-interquartile range for this one, which would be 60 minus 56. That would be over 2, so that would be an interquartile range of 2. So in the second grouping, okay, the second sample, it's actually more spread out because the semi-interquartile range is higher. Okay, so it's less consistent, It's more spread. Okay. Yeah, that is right, 60 minus 56, yeah. Or we could write it as less consistent. Okay, now it doesn't ask you for that, but if it did ask you to compare the semi-interquartile ranges, it's quite an easy calculation. Okay, higher it is, the further spread out it's going to be. Okay, so it's less consistent. Okay. Any questions on that, guys? Let's have a wee look. Let's have a wee look. Okay, so in pack 3, okay, on page 60, there's just a bunch of data ranges that ask for the median, lower quartile, upper quartile. Okay, so if you wanted to be practice on that, gives you a bunch of different ones. I think it might organise them for you, so it makes it nice and easy. Remember the answers are at the back. Okay, so if you're using this, just make sure that you know the answers in the back. Okay, this asks the same question, but it asks you to organise it yourself. Nothing much in that. Not done standard deviation yet. Let's have a look. Oh, it's interesting. Doesn't give you any exam questions for that type. So, standard deviation. Okay, let's go back. So I'll give you a question to do before break. Okay, then we'll take a break, then we'll come back together and do our standard deviation. What do you want? 10 couples. Right, how about this one? Right, so I'll write out the question. Have a wee go at this. Maybe take you 15 minutes and then we'll have a, let's say, 20-minute break. So we'll come back together. Come back together at 5 to 8. Okay, so by the time I write this out, so even if you want to go away for 5 minutes and I'll write this question out and I'll just leave it on the screen, guys, and then we'll come back together at 5 to 8. Okay. Just resume that. Okay, just the same as the examples we were looking at. First thing you need to do, just organize them. Okay, organizing them and then splitting them up. We're getting the median. Okay, for part A, the median, also known as Q2. Okay, quartile 2. Okay, I got that as 19.5. Okay, so that's a number in between 21 and 18. Okay, so just be careful with that. Median Q1, so Q1 was 17. Q3 I got as 26. That means the semi-interquartile range, which is Q3 minus Q1 over 2, would have been 26 minus 17 over 2, which is giving me 4.5. Okay, second part of the question, okay, gives me a median to compare with. So median at part A was 19.5. Okay, median median for part B that we're comparing with was 26. Okay. Standard interquartile range for B was 2.5, and the standard interquartile range that we've just worked out for A was 4.5. Okay, so what is that telling us? Okay, so two valid statements. Second round, the median score was higher. Therefore, on average, the couples scored more points. Okay. Refer to the question and put that word average in, okay, just to make sure that you've shown the examiner that you know the median is the type of average, okay. In the second round, okay, the SIQR was lower, therefore the scores were less spread. To write that another way, more consistent. Okay, so two valid statements referring to the question and referring to the term, showing that you know what it means. Okay, guys, any questions on that? Anyone get anything vastly different? Nice one. Let's move on. Okay, so second type of question, probably the more common one of the two. Okay, looks for the mean, which is a type of average again. Okay, probably the type of average that we're more familiar with, and standard deviation. Okay, again, that is just a way of showing the spread of data. Okay, so important feature here, an important thing to note here. So there's two, so dogs just try again. Two different formulas taught. Okay, I'm just going to look at one tonight. They both give you the same thing. Okay, so it's just different ways of putting same information down. Okay, so there's no difference. So you can use one or the other. So if you've been taught it previously in a different way, I've no problem with that if you're more comfortable with that. I'm going to teach it one way, and that's fine. Okay, I'll refer to the other way, we'll have a wee look at it, just so we know it's there. Okay, but other than that, I'm not going to talk about it. Okay, so mean, again, that's just the average. Standard deviation, that's just the spread. Okay, so the same sort of analysis is going to be carried out, just in a slightly different way. Okay, now, formula for standard deviation that I'm going to use, and remember this is given on the exam paper. Okay, again, don't be put off with this, we'll go through what everything means. Okay, that's given an exam. You just need to know what everything means. Okay, give me 2 seconds. Sorry, I'm just getting my dog away. Okay, so let's just go through what each of those different letters means. Okay, so each part of that equation. Okay, so that first x, okay, and there. Okay. That's just each number. Now that will make sense when we go through an example. Okay. That x bar, the x with a bar above it, that second term there, that's just the mean, okay, or the average. N in the bottom part of it, it's just the number of numbers. Okay. Something you might not have seen before is this sigma. Okay. That's just a Greek letter. Okay. That just means sum of. Okay, that just means we're adding together. Okay. So what that sum of means, so that line sigma bracket x minus x bar bracket squared, okay? All that line means is we're adding together all the different numbers minus the means and we're squaring them. Okay, now that will make sense in 2 seconds. Okay, so that sigma just means sum of. Okay, so method for working out standard deviation. Okay, so first off you want to draw a table. Okay, in the table you want to have the headings, okay, of different columns. You want 4 different columns. Okay, one column's x, which is each of the numbers, x bar, x minus x bar, and then x minus x bar squared. All this column does is set your numbers up to organise them to try and make sure you don't make any mistakes. Now you could do this step in your head, but you'll see how you could really lose your place. Okay. So you're going to get given a bunch of data, okay, and you're going to put those numbers in X column. Seconds. Okay. total that column. Okay, so add all them up, sum of that. Calculate the mean, and I'll show you how to do that. Okay, and that's just the average. The next column, we're just subtracting the mean from each number. It's actually worse to write out than it is to actually just do. Okay. 6, we're just squaring each of those terms. So square each number and from right, put it into your formula. Right, so that's just your methodology, okay? Writing that out and reading that probably takes longer than actually doing it. Okay, so that's just going to be there if you need to refer to it. Hopefully a wee bit neater and looks a wee bit tidier than that. Okay. Working through an example, and we'll try and make sense of this. Okay, so we'll go to fast, give me a wee shout. Example 1. Okay. Price of a chocolate bar. In 5 shops is 49 pence, 44 pence, 50 pence. Okay. Calculate the mean and standard deviation. Okay, so step 1, I told you to do, just create a table. Okay, so the 4 headings are X, and X is just each of your numbers. Second heading is X bar, that's just your mean. Okay, the third heading, the third column, just be that number minus your mean. In the fourth column, it's just the number found in column 3 squared. Okay. So your 5 numbers, you just list. You don't need to put these in order. Okay. And then total. And that's just adding them up. Okay, so just in your calculator, 49, 44, 50, 55, 52, you should get 250. Okay, so just add. Okay, you should get 250. Now the mean, okay, it's probably your most typical way to calculate an average. So if you got asked to work out an average, you would probably do it this way first off. Okay, this would be the first way it comes out of mind. And it's the total of all the numbers divided by how many numbers there are. Okay, so it's that 250 divided by 5. So the total of all the numbers summed together, okay, divided by the number of numbers. Okay, So that's going to be 250 divided by 5, which will just give us a mean of 50. Okay, we're going to take that mean and we're going to put that in our second column. Okay, now I can put a line in here, separate that. Okay, that second column, it's just going to be the same number in every position. Okay, now that's just for organisation. Okay, now again, you don't have to put that column in. Okay, you could miss that bit out, but to minimise the risk of mistake, just stick it in. Okay, it takes no time at all. Oops. Okay, column 3 is x minus your mean. Okay, so all you're doing is 49 and your 50. 49 minus 50, that's it. Okay, so that in this column is 49 minus 50, minus 1, minus 6, so 44 minus 50. 50 minus 50 is 0. 55 minus 50 is 5. 52 minus 50 is 2. Then the last column is just that third column squared. Okay, so minus 1 squared is just 1. Minus 6 squared is 36. Minus, or 0 squared is 0. 5 squared is 25. Okay, and 2 squared is 4. Okay, and then it asks you to add those up. Okay, so the sum of all those numbers is 40, 65, 66. Okay, and that figure there is our line in the equation. Okay, that symbol there just means sum of. Okay, so it's the sum of all of those added together. So the sum of all of them. So that wee table is just a way to organise each single step. Step 1, step 2, step 3, step 4. Okay, all in the way to get to this. Okay, this value, 66, gets put into our equation. Okay, so our standard deviation is equal to the root of the sum of your numbers minus your mean squared divided by n minus 1, which is your number of numbers minus 1. Okay, so that's root 66, n, which is 5. Okay, there's 5 numbers, minus 1 is 4. Okay, so here's the root of 16.5 if you want to just work that wee bit out. Okay, which gives us 4.062, and that continues on. Now remember, units, okay, or if you just want to do it to 2 decimal places, okay, standard deviation, or the spread of it, would be 4.06. Okay, so in regards to how much work you need to do, certainly more work, but the equation that they give you looks more complicated than it actually is. Okay. Trick is knowing this line, you need to use this table to find it. Okay, so it's just the sum of all of those squared. Okay, it's an odd calculation. Don't know why the ins and outs of it are like that, but that's it. All right. So, two more examples, and that should take us really to time. Okay, and these are more exam type questions. Okay, so you'll get asked to calculate the mean and the standard deviation, and then again you'll get asked to compare. Now the comparison is the exact same. Okay, remember the mean is given as our average. Standard deviation is given as how widely those numbers are spread out. Okay, so how widely those numbers are spread out. So if we go into example 2, okay, the temperatures, they love a wee bit of temperature, they love price, okay, could be anything. So temperature in degrees, that's seaside resort. At noon. Over 10 days. Well, 19, 20, 19, 17, 21, 18, 17. Okay, 19, 20, 19, 17, 21, 18, 19, 24, 25, 28. Okay, so hopefully that's readable. Okay, first part question, calculate mean and standard deviation. Okay, so go through our process. Okay, go through our process. Doesn't need to be in order. 19, 20, 17. Oh no. 21, 18, 19. What's really common is missing out a number. So during the exam, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Make sure you've got an equal amount of numbers. Okay, just to make sure. Remember, total that up. Okay, so just stick that in your calculator. Should get 210. Okay, and we'll use that total to find the mean. Over number of numbers. It's an odd thing to write, number of numbers. So 210 divided by 10, okay, gives us an average or a mean of 21 degrees. Okay, we put that in our second column. 21, 21, 21, 21. Again, it's just to keep ourselves right. Okay, now we've got x minus the mean, so we've got minus 2, minus 1, minus 2, minus 4, 0, minus 3, minus 2, 3, 4, 7. Then we square them. 4, 1, 4, 16, 0, 9, 4, 9, 16, 49. And then we add them all up. Adding them all up gives me 112. Okay. So that's your sum of, remember? That's your sum of all of them, all of those numbers. Okay, that's them all added up. So that's your line, that's your first line that goes into your standard deviation. Standard deviation is equal to the root of sum of x minus x bar squared over n minus 1. That top line of the equation, okay, you just substitute in your 112. N minus 1, so there's 10 numbers in total, so that's divided by 9. Okay, root of 112 divided by 9. 3 point, oh, sorry, I just went straight for the answer. So you can write out that separate line, or you can just go straight for the answer. 5, and I'll do it to 2 decimal places, so unless it asks, do it to 2 decimal. Okay, so 3.53 standard deviation. Okay, now standard deviation on its own doesn't mean anything. Okay. Let's look at part B. Typical part B. Okay. The mean temperature at a lake side resort. That was a question. Was 16 degrees with a standard deviation of 1.8. No, 1.8. Okay. Make 2 valid comparisons. Okay. First comparison, mean temp at seaside, always refer to the question, is higher, therefore on average. Okay. An odd way to write it. You'd probably never write a sentence like that, but the mean temp at the seaside is higher, therefore on average the temp is lower lakeside. Okay, that's your first one. Your second one would be to do with standard deviation. Standard deviation, you're fine to refer to it as SD at the lake, is lower, therefore the spread of temperatures is less, and can say it is more consistent. Okay, so sounds weird, but that's what it's looking for. So the lower the standard deviation, the less the temperatures are spread out. Okay, so that's two examples. Nothing really deviates. There's no tricks to these questions. It's just a case of working through that sort of methodology. Okay, so let's have a look at a couple. So remember page 60 in booklet 3, found on Moodle. Okay, so standard deviation, it sort of introduces you in 61. Ignore question 2. Mean and standard deviations, there's nothing tricky there. Okay, miss out these ones. Okay, so we touched on these during straight line. All these ones are a straight line. Okay, so just miss out. So 60, 61, 62, 63 is standard deviation. And then it jumps a couple of pages for linear stuff and then goes back to exam questions for standard deviation on page 68. Okay, so in 68, they've got exam level type questions for standard deviation. Okay, so write down the mean and the standard deviation. Mean's just the average, standard deviation's the spread. Okay, and then there's a bunch of them. Okay, standard deviation and mean are the more typical question you'd expect out of the two. Okay, but the median and interquartile ranges do come up. Okay, maybe the case is you'll get one in non-calculator for the median and interquartile ranges, and then the calculator you're more likely to see the standard deviation, just for the simple fact you need to add up all those numbers. Okay, so it might be a possibility that you get two. Okay, so what's that, 68 and 69, they've got sort of exam type questions in that booklet. Okay, so have a wee go at them. It's got the wee story, and it's got the compare the mean and standard deviation. Okay. Remember dynamic notes. Okay, from page 92, talks about standard deviation. Okay, and then it gives you this for comparisons and where the marks come from, where you don't get marks. Okay, so that might be worth a wee read. They look like they've got smaller sentences that I was writing, so it might be worthwhile just having a wee read of that. In this as well, dynamic notes, it shows you the other equation. Maybe I zoom. Where is my zoom? Okay, it shows you the other equation. Now you get both in the exam paper. Okay, so these formula are given. You only need to use one. This one here. Okay. This one here was the one we were using. Okay, so the sum of your number minus your mean squared. So all them summed together divided by your number of numbers minus 1. Why you take away 1, I don't know why you do all this. I'm not a statistician. That's the second one. I think you're more likely to make a mistake in that one, okay? But if this is the way you did it previously, feel free to use that, okay? That shows you the methodology, okay? It's drawing up that table. This table, it doesn't have the mean, so that second column that we put in. Again, that's just personal preference. It just makes it look, or makes it easier to follow, okay? I think going straight to this takeaway part, it's easy to make a mistake. Okay, that's all I'm saying there. But it does save you 30 seconds in an exam. It's up to you. You play it. Practice a couple of questions. If you don't want it, you don't want it. Okay. So standard deviation is bizarrely it's not done well in exams. Okay, I say bizarrely because the equation looks bad, but it's actually not too. It's actually not too bad to use. Okay, so give it a good go, have a wee practice at it, see if it makes sense, and if not, we can discuss it again at some point when we're doing some revision. Okay. Thursday. Start this.